So we have a picture, but what's the equation that matches the picture? Or you're given a couple of points, what's the equation that can go along with the points? And there are 3 different types of graphs that we talked about. So each graph that we talked about, or each form of a graph, we're going to try and write the equation in that specific form. So this one here says write the quadratic equation in vertex form. So first, just write what vertex form is. So kind of think about vertex form. What does that mean? How does that look? So just write how vertex form should look for this problem. So Maggie, what does vertex form look like? Yep. So that's our vertex form. It's called vertex form because when the numbers are in the problem, the numbers represent the vertex and the axis of symmetry. Well, we don't have any numbers because we're going to use a graph over here, and hopefully that graph will help us use some values to plug into this. So we're going to come up with an equation based off of the way the picture looks over here. So there are 2 points labeled on that picture. One of them is pretty important. I mean, they're both important, but one of them would be probably a little more important than the other. Which one would you say is probably more important than the other? Julia? The vertex. So the vertex is right down here. And that vertex is at -2, -3. It's the lowest point of the graph. It's in the middle of the U part. So that's our vertex. Julia, what do you think you would do with the vertex? Plug it in. So this represents H and K. So we're going to plug those numbers into our problem. Now we don't have a Y, we don't know A, we don't have X, but we know H is -2. So Julia, when you plug it in, it becomes a +2 because it's already negative and you put a -2 in place of it. And then K is -3. So now we have what it looks like is an equation kind of coming about. We know that the vertex is -2, -3 by plugging in those numbers. They give us another point, and it happens to be the y-intercept. The y-intercept is 0 and 5. If you have a point on the graph, and it doesn't have to be the y-intercept, but it could be any point on the graph, what letters do these ordered pairs represent? If it's just a random point on the graph, it's not the vertex. Holly? X and Y. So Holly, what do you think we could do with that point that's on the graph? Yeah, you could plug it in. So now we're going to plug in X and Y. So X is 0. Y is 5. The only letter we didn't plug in anything for would be A. So Holly, what do you think we're going to solve for in this problem? A. Yeah, so we're going to see if we can find A. A tells us how wide or how narrow the graph is. And that's the only part that we need to kind of finish this equation so that we have the A, H, and K in the equation. So we're going to try and solve for A. So we still have a 5 over here. We've got the A. Holly, inside here is 0 plus 2, and then it says it's squared. What is 0 plus 2 squared? 4. So that 4 is attached to A. So that makes A 4 times A, because these two are attached together, and then we still have -3. Now we have a little equation to solve. Maddie, how do you think you'd solve this equation? Yeah, let's take 3 to the other side. And then, Maddie, divide by 4. So A is 2. So the directions want us to write an equation of a parabola. To have the final equation, we need A and the vertex, since it's in vertex form. So our equation would have a 2 for A, and then back up here we have x plus 2 squared minus 3, because that's the vertex. We don't want to plug x and y back in because then we'd have an equation with a whole bunch of numbers and you wouldn't have an equation anymore. An equation needs an x and a y. So we use the other point to help us find the a value. But after you find that a value, then you're plugging your a and then your h and k. Questions? So we've done it the other way, where we were given this information, we found the vertex, the axis of symmetry, and the y-intercept, and then we graphed it. So this is kind of just working backwards through the problem. So the second example is the other form. So we talked about 3 forms. So this one now says intercept form. So again, start with intercept form. Think, what does that look like? So intercept form, what does that have in it? Abby, do you know what intercept form looks like?
Y equals a times x minus b times x minus q.
So that's intercept form. So if it's intercept form, that means we need the x-intercepts because that's what we get from intercept form. We usually get the x-intercepts. So looking at the graph, Garrett, where are the x-intercepts of a graph?
Where it meets the x-axis.
Yeah, where it meets the x-axis. So these 2 points here are the x-intercepts, where it's crossing the x-axis. So our x-intercepts are at -3, 0, and 2, 0. One of them is P, the other is Q. It doesn't matter which is which, but both of those represent P and Q. So we're going to take those numbers and plug them in. Just the P and Q, because P and Q are in the problem up here. So we have x minus -3, x minus +2. So we have the intercepts, we're going to plug them in. What else do you think we would need to do? So thinking about kind of how we walked through the last problem, Emma, what do you think else we would need to do? So we could find a y-intercept. What else do they give you, Emma? They give us a point, yeah, right here. This is just a point. And that point is at -2, -4. So you could use the y-intercept, but they give us the point -2, -4 that we can also use. Emma, what would that point represent in our equation? X and y. So you can use -2, -4. You could also use the y-intercept if you wanted to, which would be right there. Either one of them will work, but you just need an x and y value to plug into your equation. So y is -4, x is -2. So we have -2 plus 3, which is 1. -2 minus 2 is -4. So A would be a +1. So again, write the equation. So coming back up here, this is where we plugged in the intercepts. So going back to that point, we have an a value of 1. You don't need to plug an a value of 1 in. But we have the x-intercepts of x plus 3 and x minus 2. So the directions wanted us to write an equation in intercept form. So we now have an equation in intercept form. Any questions so far? All right, so the third type of problem was actually the first graph that we talked about. And that was the graph of a quadratic function in standard form. So this was the first one that we went over. Then we talked about vertex, and finally we talked about intercept form. We did all 3 of those in like 4 days. So 3 different graphs, 4 days, and then we took a little quiz on that information. So if we're talking about standard form, this is the form that pretty much all of the quadratic functions are in. Most of the ones that we've been factoring and working with have been in this standard form, using the quadratic formula, using completing the square. And that's the ax squared plus bx plus c. And I would say that's the most common form that you're going to see. This one doesn't give us a nice graph to look at, it just gives us some information. So it says write a quadratic function in standard form for a parabola that passes through the points -2, -6, 0, 6, and 2, 2. Doesn't tell us a vertex. It doesn't give us x-intercepts. It just gives us 3 random points. But those 3 random points are somewhere on a parabola to make this graph, to make it look like a parabola. How do you think you try and work with these 3 points? Holly? So she said, this one right here is what? Your y-intercept. So our y-intercept is 0, 6. So when it's in standard form, Holly, which one of those letters represent the y-intercept? The C. So the y-intercept is usually 0, C. When it's in standard form, the C is the y-intercept. So that means in this problem, C is 6. Without doing any work, knowing that we have a y-intercept, we now know C. So let's come back up here and plug that in. ax squared plus bx, and then plus 6. Because one of those points is a y-intercept. So that's good, because now I can plug that in. Have something else to plug in. All right, so we use that point, but we have 2 other points to look at still, and we need to try and use them in some way. Because everything they've given us and all the problems, we've done something with them. So we still have a point at -2, -6, and a point at 2, 2. So what else do you think we could do? Just looking at this one point up here, -2, -6. Gavin, what do you think? It could be, but we're not sure. Unless it tells us it's a vertex, we can't assume that it is. It might be, but it might not be. But what letters do you know that it would be no matter what? Even if it isn't the vertex, what does a point represent, Kevin? X and Y. So no matter what, this point represents X and Y. It could be the vertex. It could just be a set, like a point anywhere on the graph. So since it is X and Y, we have an equation with X and Y. Why don't we try and plug it in? So we have a -6 for Y. I don't know A, but X is -2, and that's squared. We don't know B, but X is -2, and then we have plus 6. See if you can simplify this a little bit. So Julian, we have -2 squared with A, so that makes -2 is with B, so that's -2b, and then plus 6. Julian, if we take this 6 so that it's on the other side with the -6, that would say then?
-12 equals 4a minus 2.
Okay. So I'm going to box this. We kind of simplified that as far as it can go. Still have an A and a B in the problem. But we at least combined the like terms together to get -12. We squared the number with A. We kind of grouped B with that -2. We still have another point, and that other point is 2, 2. What do you think you would do with that other point? What did we do with the first point? Julian? Plug it in for X and Y, because that's the only thing it represents. So the only thing we could do is try and use it with X and Y. So we're going to see if we can plug that in for X and Y. So going back up to this equation here, X is now 2 and Y is 2. So 2 equals A. X is 2, it's squared. We don't know B, but X is 2. And then we still have that plus 6. All right, so let's try and simplify it just like we simplified the other one. So see if you can simplify it exactly like the other one that's in the box up there. Alright, so here is a second equation of negative 4 equals 4a, not squared, plus 2b. So now we have two equations, both having a and b. Thinking back through the stuff that we've done so far, the concepts that we've talked about so far. You have two variables. We need to find one of those variables, actually both of them. If you have two equations and two variables, how can you use two equations to find variables? Emma? Yeah, we can use elimination. So in math, once you use it, it's fair game to come back. You might see it again and again and again and again. And in this case, we're going to use elimination so that we can try and find A and B. Because to have an equation, we have C, but we still need A and B. We need the numbers in front of X. So we can stack these two equations right up against each other and use elimination. Emma, why does elimination work really nice with this problem? Yeah, the positive b, 2b, and the negative 2b cancel. Negative 4 plus 12 is 8. 4 plus 4 is also 8. So now we know a is equal to 1. We also know c is equal to 6. How do you find b? Adam? Yes. Thanks. Okay, so this changes. Negative 16, negative 2. So Gavin, how would we find b? You know a is negative 2. What can you do to find b? Yeah, plug it into the equation. Go back to either one of them. It doesn't matter which one. So negative 4 is equal to 4 times negative 2 plus 2b. So this one is way more involved than the other two that we looked at. So we have a negative 2 and a positive 2, going back up to the top of my screen here. Our goal was to figure out an equation in standard form. So we found 6. Holly told us 6 was the y-intercept, so we didn't do any work to get that. And now we have a being a negative 2 and b being a positive 2. So negative 2x squared plus 2x and then plus 6. So a lot more work involved because there were 3 variables that we had to find, and we didn't really know a vertex to help us find those like we did with the other ones. So your homework tonight is back in the book. The first group of problems are vertex form. The second group would be the intercept form. And then I just have 2 on there, 31 and 33, that are like this problem. They're going to be a little more involved. Please use your notes when you're going through these problems tonight. So take out this page and say, all right, this is how we did intercept form. So when I try and write an equation in intercept form, you have something to model after. Again, tomorrow we're going to review. Tomorrow's just totally review day. So we'll spend time reviewing the ways of solving a quadratic equation. Monday is your notebook quiz, also reviewing, and then Tuesday would be your test. Questions?